Welcome to all of you, and thanks to the Steamtech for giving me the continuous opportunity to be part of this family. And what they have suggested, the theme, that is the green energy, definitely. And this is the, always I say in all the webinar and the seminar, that why we talking about the boiler, right? So boiler is about your 80 to 85% of your economic backbone of our country, right? So if you belongs from any manufacturing sector, like you just name of the cement, paper, textile, petrochemical, food, beverage, or any kind, right? So you definitely have the boiler system. Okay, so now the time is that, previously just the sir has told, that we only have worried about the production of the steam, right? But right now, we are much concerned about the costing. Suppose in the single rupees is going to be increased, then the lots of we have to go through the study, which factor, how we have to minimize the cost, right? So in this field, as the theme of the green boilers, as the sir has already told about the biobriquettes, yes, it is a nice concept, and Government of India is also going to emphasis on this utilization of the biobriquettes, because the things is about, it is going to save the, what we can say, the natural resources. It is also going to contribute of your energy mix opportunity, reserving the cold reservoirs. And apart from that, the most important thing is that the government is giving the emphasis that government is going to make our people, the farmers, to annadata to urja data. That is the main concept of this green energy, because they are producing the lots of, what we can say, the agriculture, the waste they have, right? So if we combine to all, and it is a good substitute of the coal that we have seen. So that's why the government is giving the impact to make the annadata to make a urja data. Now come to the another concept of this, the green hydrogen, right? So this is also have the lots of opportunity, and the concept of this, the green hydrogen, which I am much have the deep interest and going to present and going to show the path and the roadmap about what now the challenge is associated with that, but right now with our boilers, and how it is going to make the path for this generation, right? Because previously we have aware about what we can say Lancashire boilers and ABC, CABC, right? But now the coming future, I'm talking for the next of 30 years and 50 years, definitely will have with this utilization of the hydrogen. Because the government is already giving the emphasis, government is already setting the labs or different kinds of the thing to promote the production, promote the utilization, promote the safety aspects of the utilization of the hydrogen in the boiler, right? But yes, still we can say it is in the stage of the birth, right? So why we have the challenges and how we can come over these challenges, just one by one I'm going to explain in the details of that. What is the combustion technology that we have to utilize in our boiler system, what we have to take the precaution is that, all the things I'm going to deliver in this session. So first of all, why hydrogen is, right? So it is going to solve the two most important thing about our the challenge. The first is about the emission, right? Because what the kind of the fossil fuels we are using, right, they have the lots of emissions like the SOx, NOx and SPM. But if we are going to utilize the hydrogen energy, we know it is only the way, and it is only the solution in the globe, right? The second thing is about what we are using. As you all know, suppose we are burning the coal, right? Like we can say the 3000 GCV, we are just take the example of the coal, right? But as comparison with the hydrogen, it is going to your more than 2 to 3 times of the energy associated with the burning of the 1 kg of hydrogen, right? So some important the theme that how this concept is going to be more and more opportunities coming. That first of all, the Reliance MD, Shri Mukesh Bhai, has set up one vision that 111. One means 1 kg of hydrogen is going to be produced by, cost is $1 in 1 decade, in means the 10 years. So this is what now, right now, and we all are the good fortune that we are in the stage that this fuel is going to develop along with our ages, right? Initially, when I was in the, when I was in the college of the 3rd year, means 2008, that time, the solar energy are going to be peak, right? Most of you have definitely have aware of that time. So that time what happens, the costing is going to be come up to 1 unit is 13 to 14 rupees, right? So I was also thinking that no, it can't be going to be complete in the future, right? Because that time the costing of the electricity was 2 rupees, 2.3 rupees, or in that level. Now you think, so much of the Gujarat government, so much of the Indian government is making the policy, rooftop policy. Now I'm so much surprised and to see here in the Ahmedabad and Surat and all over the Gujarat that how the solar rooftop concept is going, making all the Gujarat so much that they are power sufficient, right? And in such a way they are now injecting to the grid too also. So sometimes they are utilizing, and based on that, what are their net costing is going to be done, and how much they have injected their solar power. Based on the cost of electricity is going to be so much minimized. So in that phase also, this is the phase for the hydrogen, and coming time, the lots of what we can say, the IOCL also going to set up. Apart from the government of India is going to have the target of 55 million ton of hydrogen production. A small video just I'm going to share to you. साउंड नहीं आ रहा इसमें, थोड़ा सा साउंड नहीं आ रहा इसमें.
Our entire energy platform. We target to become net carbon zero by the year 2035.
The green energy journey is truly underway. We are reimagining our entire energy platform by integrating solar, hydrogen and battery ecosystems. It's now time to kickstart the hydrogen revolution. We are creating India's first integrated end-to-end hydrogen ecosystem. The journey will start with green hydrogen production in our state-of-the-art plants. The hydrogen will then be stored and distributed through our extensive hydrogen retail network. As the first step in this remarkable journey, Reliance is proud to introduce Made in India Hydrogen Internal Combustion Engine technology for heavy-duty trucks. A unique and affordable solution for India. These vehicles are being developed with world-class technology partnerships. Powered by this hydrogen technology, we are set to redefine the future of green mobility. Reliance will induct these vehicles into its fleet in line with the net carbon zero vision for 2035. With this, Reliance is leading the transformation towards a greener future for all of us.
So this was the vision of the Reliance Industries. Apart from that, now I'm just going to the deep of this, the technical the things. As we all know that if we are using the natural gases, then we know that it's the calorific value is approx 9,900 to 10,000. Similar way, if we go through the hydrogen's combustion, then we know that it is 28,900. So as comparison of the coal and as comparison of the carbon, it is 2.5 to 3 times higher side of that. Apart from that, as we talk about what are the latest development in the Gujarat, so just I'm going to share the two stories from here. The one is the Gujarat Gas Limited, which is in the Surat. They have also commissioned the hydrogen blending unit with the natural gas, and the another from the L&T Hazira. They have also the setup of they have set up the 8 kg of the hydrogen production units, right? So right now, just I'm going to say that this is very initial stage, right? Because the technology and the method through which we are going to use and we are going to produce the hydrogen energy is very initial stage. Right now, we have also the challenges of what method we are going to adopt, right? In the some methods, we are going to produce the hydrogen through the electrolysis and somewhere in the steam reforming system. So one by one, I'm going to talk to you, right? And the hydrogen is going to form to the different ways also. Suppose we are going to take from the coal, so that is called the black hydrogen. And sometimes we are going to use what we can say the natural gases, then it is a gray. And if we are going to use the hydrogen energy, we are getting the hydrogen energy with the method of the electrolysis by the green. It means the renewable energy, then we say it is a green hydrogen. Now the basic property, which is very important for part of the hydrogen to understand the behavior and the concept, right? Because all the combustion, storage, and the production method is only associated with the properties of this hydrogen, right? So just you see here, as just I'm going to compare with the natural gas with respect to the hydrogen, then you see the density is very, very lesser. And you see here the boiling point and the energy per unit of the mass. It is 120 megajoule per kg, right? And the another point is that, which I am going to share to you, that is the ignition energy. That is going to be 0.02 megajoule. So it is highly combustible, and the most important thing is that when we are going to fire the hydrogen, the gap between your tip to the flame length is very, very, very less, right? So there is also one major challenge with us, that the cases of the backfire, right? So these are the challenges right now we are facing with the hydrogen's combustion, right? One another important thing that I'm going to share you about, suppose we are going to produce, there are n numbers of methods right now available, but some methods are still in the, what we can say, in the lab or in the testing mode, right? Some method we have achieved, but the rate of the hydrogen production is very, very, right now it is the less. The theme, that method through which we are getting the hydrogen, that is the polyelectrolyte membrane electrolyzer, alkaline and solid oxide electrolyzers are there. So in the details, just I'm going to share to you, suppose we are going to going to adopt for the hydrolysis of alkaline, then it is the efficiency is only the 63 to the 70%. If the polyelectrolyzer we are going to use, that is efficiency to 55 to the 60%, right? And solid oxide cell, that method is just in the theoretical phase. It is in the R&D, right? So the basic, all the differences is about that electrolyzer which we are going to produce from the electrolysis of the water, right? And the method through which the electrolyzer we are going to use, alkaline and poly membrane method. These two methods are basically going to difference between the process, right? So one in the process, what we are going to challenge is about the rate of the production, and other is about the how safely we are going to extract the hydrogen from the water system. So here the total entire the system, just I'm going to share to you. Suppose we are going to get the hydrogen through the alkaline electrolyzer, right? So what are the steps are there, and what are the equipments or BOP systems are there? So just I'm going to show you in the blue color, the feed water, which is I'm going to share. After that, what we can say, our electrolyzer is coming. So where we have given the supply to the anode and cathode, right? After that, it is going to convert into the gaseous and going to collect over there. But as we know that the hydrogen is very going to be precise, because if we are not going to be proper, we are going to be maintained, then it is going to be take the ingress of air from the environment and go to the explosion, right? So in that factor, what we have to do, we have to maintain the purity of the hydrogen. So how we will do it? With the help of the dryers. So sometimes we will use the single dryer system, sometimes we have to use the double dryer system. And after that, this method, what we will do, what is hydrogen we have collected, we have to, for the transportation, we have to compress at a very high pressure. Then it is going to convert into the liquid stage. So this is the method of the electrolysis. Just I am going to share to you, where we have the two anode and cathodes we have placed, and we have giving the electrical power supplies there. So one column is going to collect the hydrogen and another column is going to collect the oxygen. So this way your gases is going to be evolved, right? And it is going to be collect over there, the anode and cathode, and from there we are going to collect, and through the processes we will do the drying system, so that present of moisture that is going to be eliminated. Previously, some friends or my colleagues are there from the PF unit. So there, the hydrogen is also going to use as a cooling media, generated cooling media. So what they have to regularly or on the daily basis, they are going to check the moisture level, right? So that is the important factor. If we are going to see the combustion properties of the hydrogen, then you can see the wide range of the flammability, because the flame length, if we are going to fire the hydrogen as compared to natural gas, the flame length is higher and bigger in size, and it has the very low the ignition energy that I have told 0.02 megajoule per kg. And what we can say, the small quenching distance from the burner and the tip of the burner where the flame is going to be produced, that distance is very less. So that is one, the risk part is there. So that is why right now where we are using the hydrogen as a combustion, we are going to design the separate burner and the separate nozzle for that, because the existing system is not going to be cope up in that way to move or to emphasize the high rate of the utilization of the hydrogen. Apart from that, the flame, the speed, yes, the flame speed is also very high, because here the quantum of the huge amount of heat energy is going to be produced. So what he will do, if the temperature is going to be more than 1000 degrees Celsius, then we know that there is a formation of the NOx, right? And abrupt huge amount of your temperature is going to be impact to your boiler and other your pressure vessels also. So that also we have to keep in mind, right? So here one I have done the air fuel calculation, right? So if we are going to calculate for 1 kg or 1 mole of the combustion of the hydrogen, with respect to that, then you see it is 14.7 is jam 1 for your hydrogen with respect to your fuel. Another important thing is about the the theme is about the storage, how we have to store the hydrogen energies and transport. So it is going to store in the form of the liquid. For liquid, we have to store at a very high pressure, right? So you have to take, or we have to give the extra power to compressor and other system, so that it is going to be converted into the liquid state. So here some methods are there. Like steam reforming, that is called the steam methane reforming, partial oxidation, autothermal reforming, pyrolysis, electrolysis of the water, fermentation of the organic material, or thermochemical splitting of the water. These are the methods are there, but basically on the industries level, only 2 methods. Right now the electrolysis method and steam reforming method, which is going to be utilized and going to be generation for the hydrogen energy. Rest all of that is still in the R&D phases. Now come to the point that definitely you have question in your mind. Okay, that little bit we have understand about the birth and the development of the hydrogen, but how it is going to utilize, right? How it is going to utilize in our boiler system, or how we can utilize in our boiler, right? So here I have just going through all the details and the little bit the parameters, right? So we are going to utilize this hydrogen with the natural gases, right? And we have to going to maintain the temperature. So here just I'm showing the DCS the picture of there. The hydrogen and nitrogen gas streams will be there. According to the pressure we have to maintain, and for there we have to set up the interlocks for high pressure and low pressure the system, so that it is not going to abrupt or drastic any abnormality cause in the boiler. So here some checklist of the interlocks for a boiler I have placed here, right? What are the drum levels? These are the common, but apart from that I have mentioned about the gas pressure low, gas pressure high, where will be the certain your SOV shut-off valve of your hydrogen gas will going to be cut out when some abnormality will be there, right? And apart from that, your regular you have to check the system that how much it is your purity of hydrogen is there, right? So now the challenges of the hydrogen firing, right? So first of all, it is going to create the huge amount of the energy that is going to be caused the overheating and the generation of the NOx. So this is one important the challenge right now we are facing, that quantum of energy, how we are going to change, or quantum of energy per unit of the area, how we are going to modulate, so that the adiabatic flame temperature that we are going to control. Just I'm just going to example, if somebody will aware from the gas turbine, so what they will do if their combustion temperature is more than 1012 degrees, so that time what they will do, they will inject the steam so that their combustion chamber's temperature goes down. Similar way, this way also we have to maintain in such a way that our temperature of the furnace or temperature of the system where this combustion is going to be take place, that we have to be minimized. This is the outline of the boiler, where we are going to electrolysis method, we are going to hydrogen. After that we have the combustion method is there, and separate part will be there where this all our heat will going to be transmit, and this is you're going to your radiation method. Heat transfer is here, it is going to your radiation method, and this heat through the radiation will be collected and converted to utilize for the steam generation. So it is absolutely it is very new concept is there. As in the morning Rohinton sir already told, only the few, it means they have told that 5 boilers they have, which is right now the working on, or they are utilizing the hydrogen energy. Yes, as the boiler department always they are concerned about the safety, right? And it is very the good thing is about. So as we talk about the safety, so the leak detection system, right? So that should be 100% proof. That should be 100% that going to be automatic, because in the level of the ppm, like the chlorine, if 0.5 ppm of the leakage of this hydrogen, it should be automatic, alarm should be generated, and automatic your supply or SOB must have to be closed, right? So that your boiler area, your energy house must be safe, people will be safe. So this system is going to be implemented with where we are using the hydrogen energy system. So right now the challenges, what we have the challenges, we know what are the opportunities with there, but challenges are there. That first is about the production, economic production, because right now it is very costly. That's why it is not still going to be much more popular. But the time when 2 years, 3 years, 5 years down the time, these are going to be available on the some lower of the cost. So that time it is going to utilize more frequently and more in way. The second is about the leak-proof systems that we have to be installed so that we can utilize safely. The drawback with this hydrogen energy as a fuel, and that hydrogen energy is what we can say it is the best carrier of the energy, right? Because we can store, we can generate at one places, and we can utilize through transportation and through the trucks to the other part of the country or other part of the globe, or through pipeline also, right? But the main thing is about we have to take the precaution of the condensations also, because if it is going to produce in such a way, then it is going to create a danger the thing. So that we have to make the priority systems always. We have to also build the infrastructure so that at some regular distance we have to make the station, hydrogen station, so that part-wise or what we can say batch-wise we can transport the hydrogen energy. This is the what we can say the total scheme is about how the green energy is coming. Either it is coming from the solar or it is coming from the wind. After that we are going through the electrolysis process, right? Or carbon capturing method. This is also one method, but still it is not what we can say using as a industrial level. Then the transportation, if hydrogen electrolysis versus we are going to use, then it is not need of the transportation. But if we are going through the liquid ammonia or in the form of the liquid hydrogen, then it need to be transported through the trucks, pipelines, or what we can say shipping. We can store it, and then we can utilize in all the n number of the industry, right? We can use this hydrogen in the steel also, chemical industries, refinery.
Excuse me, I request you conclude your
Yes,
session.
yes, I'm doing the fast. And the other systems also. Okay, we can also use this hydrogen energy as a power resources and the power generation too. So here the basic fact and basic the method is about the priority, right? So for that we have the dedicated systems we have to install, like the TCDs, detectors. These detectors are going to work on the ppm label or ppb label, so that if any traces of moisture or oxygens are there, that is going to be detect, and again we have to recycle the system. It is also going to give the alarms the system, so that we can get the details about that, the quality of that. Now the most important, the theme is about, most of you are thinking about right now what is the cost of this hydrogen, right? So just right now I'm telling to you, right now the total cost is coming to $100 to $150 for per kg of the hydrogen, right? But in the down of the line, 5 years and next of the 10 years, definitely is coming down to $1 or what we can say 40 or 60 rupees. So the day is not so far when right now we all are using the LPG gases in our house, right? But down the line of the 40 years and 50 years, definitely we are going to utilize the hydrogen energy in our household also. So we will get the food, we will bake the food, and in the secondary part, we will get the water also in our kitchen also. So that time is not so far right now. Yes, the government is also here in this segment also. Government is going to be more emphasis and going to more what we can say the best solution to utilize to production of the hydrogens. So I'm going to talk to here. The National Green Hydrogen Missions they have established, and they have the target that 5 metric ton of the green hydrogen production annually, and going to set up the electrolysis, the capacity is 60 to 100 kilowatt. Right now what we have the electrolyzer, that is only the efficiency is only the 60 to 63%. So that part also we have to develop, and that also we have to make to 80 or 90% of the electrolyzer. And apart from the cost also, Lastly, the two things I'm just going to share, which is very important, and I think this should be take to you from this session, that 33 kilowatt of the power generation is going to utilize by, or you can generate through the 1 kg of the hydrogen. So I think this, the total nutshell that you can remember from here. The second is about, that is the lucrative solution is about the reserve versus production of the coal. Because if we are going to enhance the more and more hydrogen energy, then our coal reservoir is also going to be safer, and it is going to be some more time. Because right now you know all that this coal reservoir in India we have only for the next of only the 25 to 30 years. Right. So if we are using the green hydrogen, then we can say we are going in the way of energy security and Atmanirbhar Bharat. So with this all the development, the government, R&D and IITs, these all are going to set up the labs, and so much works, and other MOUs are going on work on that, right? So this is all about regarding this hydrogen energy. So definitely we will take the question answer. So thank you to all. And I feel that you are very nice audience, you are very nice people. Thank you.
Thank you, Sri Akera, for your presentation. Now I request Sri S. Manjunath Nathan for corporate presentation from Sri Sai Power and Equipments Private Limited.
Respected dais, invitees, and delegates of various organizations, very good afternoon to all. So before going to the technical presentation, just a small look about our organization. We are representing Sri Sai Power and Equipments. We are basically based at Trichy, and we have a regional office at Surat. So we are an ISO 9001 certified company. We are basically an operation and maintenance people of power plants and thermic fluidities and all type of boilers. And we have been operating atmospheric fluidized bed boilers, CFBC boilers, WHRB boilers, and oil and gas fired boilers. And we have handled lots and types of fuels like imported coal, Indian coal, municipal waste firing, 100% municipal waste firing, biomass of various types. Hope Mr. Shugab sir has amply explained a lot of this biomass fuels. So I'm going to present a paper on utilization and the consideration during the designs. So our company is driven by this board of directors, Mr. B.V. Ramesh, Mr. Shivakumar, Mr. Tangaraju, and Mr. K. Vantachala Raja. So our products and services include operation and maintenance services of boilers and power plant, pre-commissioning and commissioning of plants, power plants, boiler troubleshooting and annual overhauling of boilers, performance testing and steam and cost auditing of boilers, energy audit, and project management services. Actually, in the project management, we do boiler auxiliaries refurbishment, sporager header modification for biomass firing, supply and execution of spares and pressure parts for the modifications, supply and execution of rotating and balance of power equipments, and also we are supplying chemicals and spares for water treatment. So our value-added services are the condition assessment of boilers, troubleshooting and servicing of all types of boilers, pre-commissioning, chemical cleaning of boilers, overhauling of boilers and its auxiliaries, alternate fuel firing methods, performance and energy audits, boiler AMC services, technical and critical manpower supply for commissioning, operation and maintenance, or any critical maintenances. Boiler retrofit performance improvements. So our boiler retrofit performance includes like sporager header assembly modifications for firing biomass fuels in the fluidized bed boilers, and air-period redesigns which are required for the modifications if necessary. Then modification of air nozzles and coal nozzles for the biomass fuel firing, remodeling of coal nozzles, boiler bed coil sleeves modifications for expansion of the lifespan of the bed coils, and air and gas ducts modifications for the pressure drop and for power savings. So we are operating with our sister concerns like Sri Sai Industries, they are specialists in chemical supplies. And Mrs. Aman Enterprises, they are actually dealing with the spare parts manufacturing. And Mrs. Sri Sai Electrical Equipments, they are supplying electrical equipments and digital electronics which are required for the power plant. So this is our prestigious client list. Okay, now we will go on to the presentation of technical paper. So the recent trends in steam generating industries. Actually, so far we have talked about the coal prices and the cost of steam, all those things we have been talking about. So actually, the biomass is an alternate fuel which has been actually considered by most of the industries because of its lower cost. So because of that, now the biomass firing in the fluid bed boiler is gaining a lot of importance. So while firing this biomass in the fluid bed boilers, so there are certain considerations to be carried out or to be thought of. So like feasibility study, the feasibility study requires the available fuel handling system, the bunker system, storage system, and the furnace modification required for firing the biomasses, then consideration of pollution control equipment such as ESPs, baghouses, then designing or taking care of the furnace modifications to mitigate the effect of slagging and foiling that is abundantly available in the biomass. Then firing of municipal waste in the fluid bed boilers, and finally the dolachar firing in the fluid bed boilers. So biomass fuel, I think I thank Mr. Shuga sir because he has amply explained these biomass fuels. So there are certain, we have given certain biomass fuels, rice husk, wood chips, groundnut shell, cashew shell, coffee husk, municipal waste, palm bunch, sawmill dust, and also he has explained so many things about the pelletization and briquetting of these biomasses. So the feasibility study, when we are utilizing the biomass in the fluid bed boilers, there are so many factors to be considered for designing the boiler or while transiting a coal-fired boiler into a biomass-fired boiler. So for that, the handling capacity mainly is to be addressed through, because coal is having a higher density and biomass is having a lower density. So we need to carefully address the fuel handling system and the storage system. And the fan capabilities, as he has already told, the airflow pattern of the fuel mass wiring has to be addressed. Then the plant layout studies for adding any equipments like air preheater or steam coil preheater something. ABC boilers also inject fuels into the system by a primary air system. So this feasibility is very, very important for injecting the fuel into the boiler. So it is to be carefully addressed, or if it is required, a PL line upgradation is very much required. Also, the biomass fuels, while feeding into the PL line, we have to additionally check the feasibility to inject the biomass fuels by overbed feeding system into the fluid bed boilers. So let's see one by one. So fuel handling system, as I have told, the density of biomass is very less comparing the coal. So the conveyors which are designed for a particular capacity has to be redesigned or to be checked for handling what is the biomass which we are going to use in the boiler. And as I said, the primary air system to inject the biomass fuel into the boiler is to be upgraded or should be ensured for its sufficient combustion capabilities. Then the furnace modification. As you know, the biomass is having a lot of volatile matter, maybe around some 60-65% and lower carbon percentage. So whereas the coal is having lesser volatile matter and higher carbon content. So the design modifications has to be carefully taken or carefully to be addressed. The modification should be based on the thorough understanding of what is the biomass fuel what you are going to use, because there are so many biomass and each biomass having a different type of combustion behavior. So those are to be understood and to be addressed or to be taken care while modifying the furnace of the existing fluid bed boiler. Then the ash particles. The ash particles of the biomass are very dangerous because these particles, fine particles of the combustion comes up to the ESP, settle out there, and the charges are if started building up, then they lead to fire and explosion hazards. So the evacuation system of the biomass ash is to be carefully designed. Then biomass, the biomass is having very high moisture content and low GCV, and we have to be very careful about designing the furnace because it produces high volume of flue gas against the existing coal. Then environmental and pollution challenges like your fossil fuels, these biomass fuels also produce fine carbon dust and ash. Okay. So this is to be contained. I think we have all talked about SOx, NOx, SPM and all these things. So the SPM is to be contained less than the government recommended pollution control levels. So we have to properly employ suitable ESPs or filter houses, bag houses. Such type of controlled mechanism has to be employed for controlling the particulate emissions. Then comes the gaseous emissions or gaseous pollutants. So biomass also emanating lot of NOx and VOCs, especially the NOx where normally the fluidized bed boilers produce less NOx. But while we are using the biomass, because of the higher moisture, higher volatile content, so this starts increasing the flame temperatures to a higher level if it is not properly controlled or properly designed in the furnace. So this may increase your NOx levels. So the furnace modification plays an important role to mitigate these NOx levels. Also certain techniques like staged combustion and flue gas recirculation are to be also thought of. And slagging and fouling, as Suga sir has explained, so it is having a lot of highly volatile matter, volatile alkalis especially. So these alkalis will contribute to lot of slagging and fouling characteristics. He has given a very good picture, the fouled and slagged boiler. So while considering this biomass firing in the ABC boilers, the furnace modification has to be properly taken care to mitigate this slagging and fouling characteristics of the ash particles of the biomass. Then municipal waste firing and ETP sludge firing. So in firing this ETP sludge and municipal waste, the chlorine poses a very big threat to the boiler pressure parts. So we have to be very careful in designing the suitable metallurgy for the especially superheaters and other metal parts. Otherwise, this chlorine will attack the pressure pots and it will lead to a lot of failures, cracking, so many things. Then dolacher firing. So dolacher, now most of the sponge iron plants and steel plants have started because of the lower coal prices. So now dolacher is also available as a very big fuel and is a cheap fuel for the sponge iron plants. So the dolacher becomes a byproduct from the sponge iron. So it is having a lot of ash content. So firing the dolacher in a AFBC fuel poses a lot of challenges since it is having a lot of ash and it is very less, having less calorific value. So for firing this, there are certain modifications in the fail firing system, especially with respect to the spurger header system and hopper bottom furnace designs, all those things we thought of. Like the spurger header modification is to be considered for the dolacher fired boilers or the boilers with the existing design, windbox design has to be modified for a spurger header design. So for that, PA header ducting has to be modified, fuel transportation and coal nozzle system has to be modified, and spurger header assembly with air nozzle has to be provided. And to accommodate all these things, from windbox type to open bottom type, hopper has to be implemented to accommodate all those things, structures, all those to be modified. Also, we need to be very careful about this FDR distribution for firing this low ash fuel. So transitioning from coal-fired boilers to this biomass and dollar-fired boilers presents very promising opportunity for the current entrepreneurs to reduce the steam and fuel cost. Okay. So for firing this biomass and dollar share, municipal waste, all these things, a comprehensive feasibility study is to be carefully done, and a system to handling system, especially handling system and the furnace modification has to be taken very carefully, and these things are very crucial in handling this biomass firing. And environment pollution challenges associated with biomass firing, I think I have already covered it. The suspended particulate matter and the gaseous pollutants, and especially the ash removal system has to be carefully thought of. If you are accommodating all these things and taking care of all these things, we are sure that the industries can successfully adapt a biomass firing system and dollar share firing system in the current AFBC and CFBC boilers very well, and this will definitely reduce the cost of your steam and power. Thank you.
Thank you, Sri Manjurathan, for completing his session in prescribed time. Now, I also request Saket people to give some more time to individuals, because every speakers are not able to contribute their knowledge in just 10 to 15 minutes. So, it is time to think that in next time some more time has to be given. If one speaker is not able to complete and is complete before time, then it will be our luck. Now there is an introduction session, and now this is a topic that you have for the future. So you have to take more interest in this topic. And how many questions are arise from your side, that will decide that you have how much taken the interest in this session or you have enjoyed the post-lunch session. Now, any questions from?
सर सुभाष सर से प्रिय क्वेश्चन, आपका प्रेजेंटेशन में नोक्स का था। एक तो मेरा क्वेश्चन है नोक्स बढ़ने का रीजन और उसको कैसे कंट्रोल कर सकते हैं अगर बढ़ गया तो कोल फायर बॉयलर में।
सर नॉक्स सो नॉक्स बढ़ने का मैंने आई हैव गिवन इट एग्जांपल ऑफ ऑयल एंड गैस, but in solid also you have a larger surface area into the boiler where the temperatures are restricted between 700 to 800 degrees Celsius in the combustion chamber, then NOx production in itself will be less. So in our boilers which we give, which are, so there in oil and gas fired boiler, first I will explain, there are larger surface areas and the larger circulation ratios of the water, because of which the temperatures are restricted between 700 to 800 degrees Celsius. We are not allowing the temperature to go up beyond a point. So because of which the NOx levels get controlled, and also the burner which is put into it, because of an ECR in nature with separate servo motors for air, gas or liquid fuel, it enables a better combustion. As a result of which the NOx is reduced in the level of between 50 to 100. That is where we are giving. And in case of a solid fuel, again it is the similar thing, but it also depends on fuel to fuel. Not every fuel we are guaranteeing NOx in that range. So certain pure biomass fuels like a briquette which is based out of a bagasse based briquette.
बायोमास तो 100% कोल में रिप्लेस नहीं कर सकते क्योंकि टरबाइन चल रहा है।
100% नहीं कर सकते सर, लेकिन पावर प्लांट में I won't be able to comment because
अगर बायोमास ज़्यादा यूज करना है तो फर्नेस का वॉल्यूम भी बढ़ाना पड़ेगा।
फर्नेस का वॉल्यूम बड़ा करना पड़ेगा because heat release rates are different for biomass and for coal fired.
अभी जो पॉल्यूशन के नॉर्म्स है उसमें तो SOx कंट्रोल कर सकते हैं, SPM BSP में कर सकते हैं, लेकिन NOx
के लिए कोई इक्विपमेंट नहीं है। नॉक्स आप पूरा कंबशन पे ही कंट्रोल करना पड़ेगा।
एफबीसी में ज्यादा टेम्परेचर भी रिड्यूस कर सकते हैं।
नो,
क्लिंकर का चांस।
I won't be able to comment on EFBC because we don't manufacture that. I'll be able to comment on process boiler which I am commenting. So for oil and gas we can definitely do it.
सॉलिड फायर में नॉक्स कंट्रोल करने के लिए सेकेंडरी सिस्टम स्टेजिंग कंबस्शन वी कैन से, कि हमको स्टेज में ऊपर जाके उसको टेम्परेचर अल्टीमेटली जो उन्होंने बोला वही है, टेम्परेचर रिड्यूस करना पड़ेगा। आप अगर 1000 डिग्री के ऊपर अगर फ्यूल रहेगा तो टेम्परेचर रहेगा तो आपका नॉक्स जनरेट होना ही है। तो उसको रिड्यूस करने के लिए सेकेंडरी एयर हमको सप्लाई करना है, स्टेजिंग सेकेंडरी टर्सरी। फिर अभी आजकल तो पीएफ बॉयलर में क्या करते हैं, सेकेंडरी ओवर फायर एयर या रीसर्कुलेशन कंबशन, इस टाइप का सिस्टम है। और एफबीसी बॉयलर में तो वैसे ही टेम्परेचर 850, 800, 850 तो
एयर भी प्रोविजन देते हैं।
हाँ, तो उसमें ज़्यादा नॉक्स जनरेट होने का चांस ही नहीं है, इसीलिए अपने एफबीसी में आए ताकि टेम्परेचर आपका कम कर सके, नॉक्स जनरेशन कम हो सके। ठीक है।
दूसरा एक क्वेश्चन है सर, हम फेस कर रहे हैं बॉयलर में फीड वाटर में पीएच नॉर्मल आ रहा है 9, लेकिन ड्रम में कम हो जाता है। डोजिंग भी करते हैं टीएसपी का, फॉस्फेट लेवल बढ़ता है लेकिन पीएच डाउन होता है। और पीएच कब बढ़ता है, जब ब्लो डाउन ज़्यादा देते हैं तभी पीएच राइज होता है। उसका रीजन नहीं मिल रहा है, वो रीजन पूछना था।
आपका
फीड वाटर में नॉर्मल है, ड्रम में जा रहा है डाउन।
आपका बॉयलर ही खुद, आपका प्लांट ही खुद काफी कॉम्प्लिकेटेड है। और जो जिस हिसाब से आप पूछ रहे हैं
सर, हम तो आप एक्सपर्ट से
सारे के सारे इश्यू है।
नहीं, इश्यू जो है वो एक्सपर्ट से इसलिए पूछते हैं कि जवाब मिले इसलिए।
हाँ, बिल्कुल सही बात है। कहीं
अगर ऐसा
हाँ, तो मैं आपको यही बोलने वाला था कि आपका जो कंडेंसेट आ रहा है वो
कंडेंसर रिटर्न नहीं ले रहे,
जीरो
डीएम वाटर आ रहा है ना,
पूरा डीएम वाटर
ही कंडेंसेट नहीं है।
और डीएरेटर में आपका पीएच वगैरह सब मेंटेन हो रहा है।
डीएरेटर में बरोबर, फीड वाटर में वही कोई इनलेट तक बरोबर है, जो भी होता है ड्रम में होता है।
देखो पीएच डाउन,
इसलिए आपके एक्सपर्ट एडवाइस लेना है ना।
नहीं एक्सपर्ट, then expert is required to visit the plant.
आपका जवाब नहीं मिला है।
Expert is required to visit the plant. What you are saying, whether it is correct?
सर, एक्सपर्ट तो तुरंत जवाब दे सकता है, विजिट के प्रॉब्लम यही है।
नहीं
एक्सपर्ट किसको बोलते हैं, तुरंत जवाब दे उसको बोलते हैं ना।
सर,
आपका जवाब देने के लिए
जेन्युइन प्रॉब्लम है, हंसने का नहीं है। हर जगह होगा, आपके प्लान में भी होगा। बोलते नहीं है आप लोग।
नहीं, सबके प्लांट में रहते हैं, सब बोलते हैं, ऐसा नहीं बोलते हैं, लेकिन
हंस रहे इसलिए बोल रहा हूँ।
सुनिए, अगर आपका फीड, आप जो फीड कर रहे हैं, देखो दो चीज होती है, डीएरेटर में जो फीड कर रहे हैं वहां से अगर पीएच आता तो पीएच डाउन जाएगा। क्यों? आप डोजिंग प्रॉपर कर रहे हैं, आप बोल रहे हो फॉस्फेट में बराबर डाल रहा हूँ, पैरामीटर मेरा सब बाकी का ब्लो डाउन में जो भी है बराबर आ रहा है, तो फिर और चीज कहाँ से जनरेट हो रही है, मैं वो जानना चाहता हूँ आपसे।
नहीं, ये मुझे मिल नहीं रहा, इसलिए एडवाइस ले रहा हूं।
सर, आपका क्वेश्चन बहुत अच्छा है और मैंने भी ये 2-3 प्लांट में इश्यूज देखा है, खासकर अपने गुजरात रीजन के लिए। मैं आपको 2 ही चीज़ बोलूँगा, आप जा कर के, इतने सारे लोग बैठे हैं, आप जा कर के ये चीज़ चेक करना, डेफिनेटली आपको फ़ायदा होगा। द फर्स्ट थिंग इज़ अबाउट देयर इज जनरेशन ऑफ द टीओसी, जो कि आपके मोस्ट ऑफ द प्लांट में टीओसी आप चेक नहीं करते हो। आपका बॉयलर का वर्किंग प्रेशर कितना है सर? आपके बॉयलर का वर्किंग प्रेशर कितना है?
82 kg।
82 kg। इसका जो ग्राफ रहता है ना, 82, 113, 115 kg के जो बॉयलर्स हैं ना, जहाँ पे उनका सैचुरेशन टेम्परेचर 320, 360, 380 के रेंज में आता है, तो वहाँ पे जो टीओसी है, टोटल ऑर्गेनिक कार्बन, वो उस टेम्परेचर पे, पर्टिकुलर उस टेम्परेचर पे दे आर गोइंग टू फॉर्म द ऑर्गेनिक एसिड। जब ऑर्गेनिक एसिड आपका बॉयलर में बनेगा ना, मैंने भी ये चीज़ फेस किया है, सर को भी मालूम है, ये चीज़ हमने भी फेस किया है। तो वो क्या करता है ना, आपका सब अच्छा रहेगा, आपका इको इनलेट अच्छा रहेगा, आपका फीड वाटर पीएच अच्छा रहेगा, कंडक्टिविटी भी अच्छा रहेगा। जो भी आपका कंडक्टिविटी 1 या 2 अगर आप आफ्टर द डोजिंग, अमोनिया डोज करने के बाद या पीएच बूस्ट करने के बाद जो उसका डोजिंग आ रहा है ना, वो परफेक्ट होगा। ड्रम में जाके आपका पीएच डाउन हो जाएगा। जनरली आपका एक और टेंडेंसी क्या रहता है, टेम्परेचर जैसे ही आपका बढ़ेगा ना, ठीक है, तो पीएच डाउन जाता है। लेकिन एक बार आप अपना टीओसी चेक करना। दूसरी चीज़, जो आप टीएसपी डोज कर रहे हो ना, ठीक है, उसमें जो कमर्शियल टीएसपी जो आ रहा है उसको भी एक बार चेक करो, क्योंकि जो मार्केट से हम नाम लेते हैं क्या कि हम टीएसपी परचेज कर लिए, ठीक है ना, उसको बोलते हैं आपको एक उसका ट्रेडिशनल नाम है, उसका डिटेल है मेरे पास, लेकिन उसमें जनरली बाय वेट ओनली 18% ही फॉस्फेट रहता है। और ये फास्फेट आपका दो मेजर इंपॉर्टेंट काम करता है. द फर्स्ट इज अबाउट इज डूइंग द कंडीशनिंग. जो उसमें इवापोरेशन साइकिल ऑफ कंसंट्रेशन बढ़ रहा है, तो वो जो स्लज जो
सर इसमें एक ऐसा है, एक पैटर्न ऐसी देखने को मिल रही है, ये जो प्रॉब्लम आता है ना
जी,
उसके आगे हमने एसएससी और एसबीए का हम साथ में रीजनरेशन लेते हैं, तो उसके टाइम
देखिए ये जो बात आपने बोला ना, दैट इज अबाउट द आयन एक्सचेंज, वो डीएम प्लांट का बात है. ये जो बात कर रहे हो दैट इज यू आर टॉकिंग अबाउट द बॉयलर ड्रम.
सर
सीबीडी का बात कर रहे
सर ये जो प्रॉब्लम सीबीडी वाला जो पीएच डाउन आ जाता है ना, वो तभी आता है जब एसएससी एसबीए का रीजनरेशन होता है, तभी ये प्रॉब्लम ऑब्जर्व हो रहा है.
यस, तो उसमें क्या है, बहुत अच्छी चीज है, आप खुद अपने प्लांट का प्रॉब्लम को आप सोल्यूशन तक आप पहुंच रहे हो. मैं खाली दो ही चीज़ बताऊंगा. उसमें क्या होता है ना कि जब रीजनरेशन करते हो ना, तो उसमें जहाँ पे रीजनरेशन का है ना, तो उसमें जो वाल्व लगे हुए हैं ना, वो सब जो प्लंजर टाइप वाल्व हैं, वो 100% सील नहीं रहते हैं, वो लीक हो रहा है, वहाँ से पासिंग हो जा रहा है. तो एक बार उसको भी आप,
पर पीएच वहाँ तो सही आ रहा है ना, डीएरेटर तक सही आ रहा है, पीएच फिर कहाँ सवाल है.
तो एक
डीएरेटर तक सही आ रहा है ना.
एक बार आप,
अगर आपका एक्सचेंजर में कहीं प्रॉब्लम होगा तो डीएरेटर में रिफ्लेक्ट करेगा ना. हाँ, फीड में भी नहीं आएगा.
ड्रम का एक बार आप सैंपल लेके देखिए. आप ड्रम का आप सैंपल लेकर के उसमें फास्फेट भी चेक कर लो,
हो सकती है,
फास्फेट चेक कर लो,
आपका
टीओसी भी आप चेक कर लो कि वो प्रॉपर हो रहा है या नहीं हो रहा है. ठीक है. दूसरी चीज है क्या सर, एक चीज और उन्होंने बताया कि जब ब्लो डाउन देते हैं तो सही होता है. एक्चुअली मैं इससे काफी डील किया हूँ. फास्फेट क्या है ना, फास्फेट ऐसा चीज है कि अगर यहाँ पे भी अगर गिर गया ना, तो आप झाड़ू मार करके भी हटा नहीं सकते हो, ऐसा उसका टेंडेंसी है. तो हो सकता है कि जिस रेशियो से जो हम लोग बोलते हैं 2.8:1 के रेशियो से हमको मेंटेन करना है, क्या उस मेंटेन से जो फील्ड वाले जो ऑपरेटर प्रिपेयर कर रहे हैं वो हो रहा है कि नहीं हो रहा है. क्योंकि ब्लो डाउन जैसे ही दे रहे हो तो मतलब क्या हो रहा है कि वो फिर डाइल्यूट हो रहा है. देन इट इज गोइंग टू शो द रिजल्ट. तब तो रिजल्ट दिख रहा है ना, तब आपका पिच बढ़ रहा है, बट लेकिन पहले नहीं बढ़ रहा था. तो कहीं हम बहुत ज़्यादा एक्सेसिव डोजिंग तो नहीं कर दिए हैं.
फॉस्फेट कम कर दो ना फिर.
ठीक है. वो एक दो चीज़ सर भी बता रहे हैं कि एक दो बार आप ट्रायल लेकर देखो कि जितना आप जनरली कितना होता है, जनरली 2.5 से 3 kg ही फास्फेट डोज होता है, मतलब सॉरी टीएसपी डोज होता है बॉयलर में पर डे. आप देखो कि आप अपने बॉयलर में कितना पर डे डोज कर रहे हो, और फिर भी अगर कोई दिक्कत है तो एक बात बताओ मुझे.
ये रेगुलर प्रॉब्लम है, कभी कभी आता है.
आता है, कभी कभी आता है, रेगुलर नहीं है.
और ठीक है, इतना चीज जो बताया ना
कि जब रीजनरेशन करते हैं तभी आता है.
अच्छा,
वो उनका डाउट ये है कि भाई डीगैसर काम नहीं करता हो, नॉन कंडेंसेबल गैसेस रिमूव नहीं होता हो, तो हाई टेम्परेचर में हो सकता है.
नहीं, देखिए डीगैसर का क्या फंक्शन है, और डीगैसर के आउटलेट में भी ना जो रेसिडुअल जो CO2 होना चाहिए वो लेस देन 5 ppm होना चाहिए. तो ऐसा पावर प्लांट में कुछ भी ऐसा चीज़ नहीं है जिसको आप आइडेंटिफाई करके उसको सॉर्ट आउट नहीं कर सकते हैं. खासकर अब तो पावर प्लांट का चलते हुए भी 20 साल 25 साल 30 साल हो गया, तो अब कुछ इम्पॉसिबल है नहीं. आप
कौन सा कंपनी है आपका?
चीज कीजिए, हो जाएगा.
सोलारिस.
ठीक है, हो जाएगा.
ओके, थैंक यू.
कोई दिक्कत रहे तो बताइएगा फिर.
रॉबिन प्लांट, रॉबिन
सर. सर, बायोमास टू कोल रेशियो जो स्टीम टू कोल और स्टीम टू बायोमास, उसका जो रेशियो है उसमें कुछ फर्क पड़ता है सर? कुछ रिड्यूस होता है?
जीसीवी के ऊपर है, जो ब्रिकेट का जीसीवी आएगा उसके हिसाब से आप कैलकुलेट कर लो.
क्योंकि उसका जो ब्रिकेट्स का जो बॉन्डिंग रहता है उसमें कुछ केमिकल्स वगैरह रहते हैं, उसकी वजह से कुछ इफेक्ट आता है सर उसमें?
नहीं, केमिकल्स कहाँ रहते? ब्रिकेट में कोई केमिकल
जो बॉन्डिंग होता है
नहीं, कोई बॉन्डिंग, कोई केमिकल यूज नहीं होता है. दैट इज श्योर. वो प्रेसिंग है, ओनली प्रेसिंग, कंप्रेसिंग.
ओके,
ठीक है.
थैंक यू.
बिल्कुल कर सकते हैं, लेकिन वही अगेन मैं बोला, जो फाउलिंग कैरेक्टरिस्टिक वो बढ़ता है. डीओसी आप बोल रहे हैं? You are right. DOC is very limited fuel is available, and people are not using as a fuel, but using as a cattle feed. So that's why. Yeah, exactly. It's a good fuel. I am not saying it's a good fuel. It's a good fuel. Not clear. We cannot say clear fuel. We cannot say as a clear fuel, but it is having a sulfur also and high. But high amount of this fouling characteristic. Now, definitely we can use a DOC as a fuel. No issue.
एक ही पॉइंट रहता है कि कैस्टर का शेल हो या ग्राउंडनेट का शेल हो या कैश्यू का शेल हो, these all shells have low fusion temperature, तो ये ग्रेड पे चिपक जाता है. So burning them is not so easy. So you will have to mix in proportion, point number one. And it also depends on what is the quantity available to you. Like as a company, we burn a lot of moisture-based fuel and as well as the fuels you are saying. We have given boilers on cashew nut shell, on groundnut shell. Castor I have not heard, but I don't know. They might have given it.
No, DOC you are using 100% also, but how many days you are running the boiler?
Yeah.
See, we run the boiler for 6 days, even in other plants.
Yes.
It's a 24/7. See, for my plant, we are running only for 6 days. Sunday we stop the plant.
Then cleaned.
In other plant, we have a 24/7. Even my Palanpur plant, it is also 24/7.
No, 24/7, but how many number of days? 30 days, 40 days? Not possible. Not possible. But small plant then. Not maybe talking about the 10 ton, 15 ton, 20 ton boiler. Small boiler. Yes, exactly. Exactly. Yeah. Quantity, depends on the quantity. Very small boiler.
Because see, recently you might have gone through the notification from CPCB. They have declared certain agro fuels with the certain parameters of the SOx, NOx and what you call PP, particular matters. Right? So that advantage we would like to take on this particular thing. Because nowadays CPCB norms are different and if it is from the CPCB, definitely CPCB to honor this notification. And that is why I am just debating.
Okay. Good thing. So any more questions, please?
गुड इवनिंग सर. जैसा कि आपने ग्रीन हाइड्रोजन के बारे में बताया, तो मैं ये पूछना चाहूँगा कि क्या आपने अभी अमोनिया प्लांट या यूरिया प्लांट में भी इसको कहीं इम्प्लीमेंट किया या कहीं ऐसा कोई केस स्टडी है अभी रिसेंटली इन इंडिया?
हाँ यस सर, अभी ये काम चल रहा है. अभी मॉर्निंग में ही इंडस्ट्रियल बॉयलर्स वाले ने भी बताया कि करीब उन्होंने 5 बॉयलर्स दे हैव स्टार्टेड विथ द हाइड्रोजन, green hydrogen, like the ammonia also. They are also using the ammonia synthesis process, and their byproduct, the hydrogen, is going to be generated. So now, but the numbers are very less. We can count it on the fingers.
मतलब अभी कोई सक्सेसफुल कंप्लीटेड कोई टास्क नहीं हुआ ना?
नहीं चल है ना,
अंडरगोइंग है.
नो 30% लोडिंग पे अभी जो मैंने भी जो आपको जो डेटा दिखाया वो ऑलरेडी रनिंग है. 12 टन का बॉयलर पे अभी वो चल रहा है. And in coming future, in next 1 and 2 years, this number is going to be more. चल रहा है. The firing of hydrogen. I understand about that. You are asking about the question that hydrogen is being going to fired in boiler, or still it is in the what we can say in the design.
I mean, no. It's in prototype zone or it's
no. It is running. It is also hydrogen industrial use. It is going on. Already I have shown the details of the 12 ton of the boiler, which is 30% loading is going to be governed through the green hydrogen, right? And in the similar way, this green hydrogen is also going to use in the gas turbine also with your natural gas, right?
So, but the question is, I'm asking in regard with ammonia plant. Suppose if we are producing ammonia, so the green ammonia, the new Yara which works on that. Yara currently signed a pact for working on green ammonia and green urea for reducing the carbon dioxide. And so, in what sense you are processing in that direction? Is it green hydrogen is similar to that direction, or both are different tasks?
As to talk about the green ammonia, it is also the similar way as the hydrogen is going to be produced, right? But right now it is in what we can say in the prototype. the commercially, which is going to be next in the phase wise in the IOCL, they are going to generate it that.
Okay, so you mean any consultant or any project is there who are working on green ammonia or green?
Yeah. There are n numbers of the projects and the consultants are there. They are working on that. And government is also, they have packed the budget and they are going to 9,000 of this development, consultancy, services, and the target for the per year 5 metric ton of the production.
Because we at IFCO, we are producing ammonia and urea. That's why I'm asking this question in regards of that.
Yes, absolutely. Because in the IFCO and some, you're also unit in what we can say in the Shahjahanpur or some unit at...
that is CRIPCO. I'm IFCO, IFFCO.
Okay.
Kalol.
Yeah, in CRIPCO they are doing.
Okay.
CRIPCO
they are doing?
Yeah, I have got the news that they are doing. CRIPCO is doing, but in very smaller and lesser quantity of that.
Okay, fine.
Yeah. Okay. In some places also that is the Rashtriya Fertilizers Limited, like in Gorakhpur. RCFL. They also doing in the same way, doing for the green ammonia. Mm-hmm. Right. But right now I'm not get the data that how much quantity they have confirmed or they have cleared the COD. Right. But definitely in coming 1 and 2 years we will get the lots of the details about that. But work is started.
Hello. Thank you for taking keen interest, because we are already running by 1 hour late. Now, in our starting conference, we are talking about how boiler efficient we can run, efficient boiler operation. And nowadays we have to think about the green fuels, that this boiler running is shifted over to the main on fuel. So we have to think for our fuels that how we can use hydrogen as a fuel more and more. In other countries like Germany, they are started running the train on hydrogen. So we have to think that hydrogen can be used more and more. We have to think, rethink, and overthink about the hydrogen uses, green fuel uses of in our particular industry. We consume water as a human being. The human can also produce hydrogen instead of hydrogen sulfide. If we think it's okay. Thank you.
So thank you very much, panelists, for the excellent sharing that you have done. Friends, unfortunately we are running quite a bit late, and I do not wish to give a break so that we would go further late, because we already have the final people in the last session here. And right away, we will not have any break. We will right away start this session. So I'll request every one of you to kindly be seated in the auditorium. Do not venture out. You will get tea after the conference. Don't worry. So you may have a lot of question answers, but this session is going to be a panel discussion, and you'll get more time to have answers of your questions. So keep your questions with yourself and be ready for the next session.